Now, this one, two-stage binomial. So they give a context. You need to use binomial distribution to find probability for that. So binomial distribution, eventually it gives you probability in a simplest way. And then you use that for the next condition. Let us try to understand this one. A student arrives to school on time, probability is 0.8 on each day. So binomially distributed, probability is 0.8 here. Independently, a week has 5 days. So we are looking for 5 days stuff. X is the number of days in a week. If you see, they gave variables, two variables. The moment you see two variables, this would be different to this one. So this is a different distribution. This is a different distribution. And here, X is the number of days in a week she is on time. If you remember in the previous videos, we have discussed definition of this variable is really crucial. So number of the success is she is on time. The number of days she is on time. So ignore just this part. Generally, the question would be like this. A week is called a good if student is on time at least 4 days. So the success is student being on time. Student being on time is a success. If student is successful at least 4 times, the moment you see at least 4, probability of X greater than or equal to 4, at least in order to say that that is a good week, the student should be there at least 4 days present. So probability X is greater than or equal to 4. You use the calculator for that. So if you use the calculator for that, sorry, I have to show from this one. So the calculator, if you use the calculator, at least 4 times successful. Lower bound is 4, upper bound is 4. Total number of trials are also 5. Sorry, upper bound is 5 and number of trials are 5. You got probability 0.7328. So you get probability for this 0.7328 for this. We are done with this one. Now we go to the next variable. Let us try to understand. If this one. Over a half term of, this is completely different context. Over half term of 8 weeks, let Y be the number of good weeks. Now variable is number of good weeks. Now the success is being a good week out of 8 weeks. N becomes 8 out of good weeks. We need to know probability of having a good week. We know that from the previous question, probability of having a good week is 0.7328. Now, how many good weeks they need? They said at least 6 good weeks. Now, we know that P of X greater than or equal to 6, P of X greater than or equal to 6, and you write lower bound is 6, upper bound is 8, and the number of trials 8. You enter P as this one, you should get the final answer. This is how two-stage binomial would be. And for example here, I'll quickly pause this video and try to solve this. So this one, if you see the first probability X is number of correct items in a batch, in one batch. So we'll use, they said that to call a batch is clean, out of 10 items, at least 9 items should be clean. 9 items should be clean. So P of X is more than or equal to 9. You get the probability there. So to get it is clean, probability should be more than or equal to 9. Then probability, whatever the number you get, that tells you that probability, the week being is clean, not week, sorry, I'm mixing up the previous question. The batch is being clean is this one, whatever the number you get. And then there is a different distribution. See, there is X and there is C now. C is the number of clean batches. Number of clean batches. Now, this probability will become this number. This probability, the previous probability becomes this number because we need the probability that batch is clean. The batch is clean probability is this one. And then this is 20. They're asking for 18, at least 18 clean batches more than or equal to 18. You do the calculation and you should get this answer.